In this video, we'll look at coterminal angles. In particular, we will define coterminal angles and look at how to find angles between 0 and 1 full rotation, which are coterminal with a given angle. And we'll do this in both angles measured with degrees and angles measured with radians.
When we later start looking at the trig functions of angles, the one key important property of that angle will be the location of the terminal side. In particular, if two different angles have the same terminal side, then the trig functions for those two angles will agree. And therefore, it's useful to know when two angles have the same terminal side, and this is important enough that we give this property a name. So we say that two angles that are in standard position are coterminal if they have the same terminal side. For example, let's say we have a 45-degree angle in standard position. So this would mean that it has its initial side on the positive x-axis and a terminal side pointing along the line y equal x. So this will be a 45-degree angle. We can look at another angle with the same initial and terminal sides by starting with this initial side on the positive x-axis and rotating it around clockwise until we hit the same y equal x line. If we did this in degrees, this angle would be negative 315 degrees. It's negative because the rotation is clockwise, and it's 315 degrees because that is the amount of rotation needed to get to the line y equal x. And there are in fact several other ways that we could go from our initial side to our terminal side. One other option would be to rotate in the positive direction, but to rotate around one complete rotation and follow that up with another rotation of 45 degrees. If we measure the degrees for this angle, we see that this would be 360 degrees for the full rotation, plus another 45 degrees, yielding a total of 405 degrees for this angle. All three of these angles are coterminal. They're all in standard position, and they all have the same terminal side. If we look carefully at these three angles, what we notice is that they differ from each other by a full rotation or by multiple full rotations. So for example, if you pick any two of these angles, 45 degrees, negative 315 degrees, and 405 degrees, and you subtract the 1 degree measure from the other, you will obtain either plus or minus 360 degrees or plus or minus 720 degrees, all of which are multiples of 360 degrees or one full rotation. And this is the key observation to make regarding coterminal angles, that they differ by complete rotations. If we're measuring our angles in degrees, then that means coterminal angles will differ by multiples of 360 degrees. And if we're measuring our angles in radians, they'll differ by multiples of 2 pi radians. So in order to produce an angle that is coterminal with a given angle, we can either add or subtract 360 degrees or 2 pi radians as many times as necessary to get an angle that we are comfortable with. Typically, this means between 0 and 360 degrees and between 0 and 2 pi radians. In this example, we'd like to find an angle theta with degree measure between 0 and 360 degrees, which is coterminal with one of 800 degrees. Since coterminal angles have degree measure differing by multiples of 360, one approach to do this is to continually subtract 360 degrees from our angle measure until we hit something between 0 and 360. So here we're going to start with our 800 degrees and subtract 360 degrees. And when we do that, we will obtain 440 degrees. This angle is still too big, and so we subtract another 360 degrees from this one. And in doing so, we end up with 80 degrees. And this angle is in our desired range. And so what this is telling us is that an 800-degree rotation will rotate around counterclockwise twice, corresponding to the two 360-degree rotations that we've subtracted off, and end up pointing at 80 degrees. So if we wanted to sketch this angle, the terminal side of this angle would be at the same as the terminal side of an 80-degree angle, which would be something like this. Right, so if this were an 80-degree angle here, our 800-degree angle would have the exact same terminal side, but it would have rotated around completely twice before landing at that position. In this example, we want to find an angle theta measured in degrees between 0 and 360 degrees, which is coterminal with one of negative 45 degrees. This angle is smaller than 0 degrees, and so in order to find one in the appropriate range, we want to add multiples of 360 degrees until we obtain one between 0 and 360. And so negative 45 degrees plus 360 degrees will be 315 degrees, which is in our desired range. And so negative 45 degrees would be coterminal with an angle of 315 degrees. While it's not the case here, if this number were still negative, we would then repeat the process. We would add another 360 degrees, and then possibly another 360 and another 360 until we arrive at a positive value that's less than 360 degrees. So this angle is quite easy to see that these angles are coterminal. We have this angle here, and if we rotate in the negative direction 45 degrees, we'll obtain this. The terminal side here will be the line y equal negative x, and a 315 degree angle will arrive at the same location, just from the rotating in the opposite direction. And so these are clear enough that these will be coterminal, and we can see here that these two angles differ by a complete rotation. If you take the negative 45 degree angle and rotate it counterclockwise 360 degrees, you'll have obtained the 315 degree rotation. Now let's look at an example using radians. Here we want to find an angle theta between 0 and 2 pi radians, which is coterminal with one of 19 pi over 4. We're going to apply the same procedure as in the previous examples, except we're going to do the calculation in radians. Since 19 pi over 4 is bigger than 2 pi, we're going to start by subtracting off one full rotation from this angle, which would be 2 pi radians. Since our angle has a denominator of 4, in order to do this, we would rewrite 2 pi as 8 pi over 4, and subtract to obtain 11 pi over 4. So 11 pi over 4 is an angle coterminal with 19 pi over 4. However, it's still bigger than 2 pi. And so in order to continue this process, we're going to subtract 2 pi from this angle. Again, this would be 11 pi over 4 minus 8 pi over 4. And this difference will be 3 pi over 4. And this is an angle that is in the desired range. It is positive and less than 2 pi radians, and so it is our desired angle. And so 19 pi over 4 is the radian measure of an angle coterminal with one of 3 pi over 4 radians. If we wanted to sketch this angle, we first would need to sketch a 3 pi over 4 degree angle. 3 pi over 4 would be 3/4 of pi. We know pi is a half rotation, so we want to rotate around 3/4 of the way to the half rotation mark. And that would be right here. This would be, the terminal side there would be along the line y equal negative x, just going in the negative direction. So this is our angle 3 pi over 4. But notice that 19 pi over 4, we actually subtracted 2 rotations to obtain that. And so our actual angle of 19 pi over 4 would go around for 2 complete rotations, and then another 3 pi over 4 units. And so this blue spiral here is representing our 9 pi over 4 radian angle, 2 complete rotations, and an additional 3 pi over 4 radians. If you'd like some additional practice, try to find these two angles. First, find an angle theta between 0 degrees and 360 degrees, which is coterminal with one of negative 870 degrees. And then find one between 0 and 2 pi radians, which is coterminal with one of negative 17 pi over 6 radians. The answers will appear in a few seconds.